So some of the other concept of the class that I have added here, you can just go through it. Okay, and I'm not going to discuss everything these things, so you can just open these files, and I have given some of the instructions here that what is the copy constructor. Okay, so it is a overloaded constructor used to declare and initialize an object from another object. Okay, and why it is important, that reasons I have also added at the last of the code. So just open these files and try to go means each this file and try to understand the concept of the different things like copy constructor. Okay, these are the some advanced concept, so that is why I did not discuss explicitly. So why destructor is important and why there should be, whenever you are going to have a user defined constructor, then there should be one destructor also. Okay, so these are the definition of the destructor, and there are the some characteristics of the destructor that you can just go through each files. Okay, similarly these are the some concept of a dictionary. Maybe when I go today, I'm going to discuss about the Doxygen, how it can be useful for you, and some of the more advanced concept of the means programming that is specific correlated to the OpenFOAM. Okay, so these things we are going to discuss, and I am going to take the topics of the dictionary object registry. That is a very important topic, and also means I will going to take example of the this dictionary, and I will explain that what is the abstract class or virtual function, and so these things so you can see that what is the friend function, and I am given some examples. So first try to start with this example, and then you can decode it, and then you can take this another examples, and you can see just whatever the things you have to understand, I have just written here. Okay, so just try to go through each of the examples, and some other concept of the class that you have discussed by Nikhil in the week 2. These examples I have added here. Okay, so some of you was asking that can we include using the header files. So you can see here that we have first used the header files, and we have means constructed one .c file, source file. Also there is one header file and .c files. So try to go through these examples, and you will have some idea about what means some more advanced concept of the class will be understood by you. Okay, because OpenFOAM completely works on the object oriented problems, and that is why it is important to understand the class. Okay, now let's start with the today's session. Okay, so OpenFOAM's utility means that open source field operation manipulation of the C++ library. So whatever the things that you see in the OpenFOAM, like pre-processing tools, solving, or post-processing, so these things have created one means object. Okay, and that we are going to manipulate those objects, and objects had some methods and functions, and using those methods and functions we are do the pre-processing, or we are going to solve, and we are going to do the post-processing. So if you classify this pre-processing, so generally these utilities and some meshing tools are categorized inside the pre-processing tools. And solving means of course we are creating the applications, and this post-processing that we have this Paravi is another that is means beyond the OpenFOAM, but Paravi is also an open source, and there are some other post-processing tools that we will discuss in the these topics of the, there will be one separate session on the complete post-processing that we are going to discuss. Okay, now generally the best though means whatever the, if you see the OpenFOAM background, so generally we are going to see either function or the class, these two things, or it can be both function and class, these two concepts, and are the combined of these two concepts that is going to be see in the OpenFOAM. So whenever you start working with the OpenFOAM, either there will be function or there will be class. Okay, even starting from the variables that we have discussed in the first class, that what are the variables. The variables is also one kind of a class. Right? Okay, so like if we say level or if we say scalar, So a scalar and this label is also one kind of a class, and this label and scalar has some functions. Okay, like you can if you are adding two scalars, that is the operator overloading concept. Okay, and if you are adding two label kind of the variables, then it is also a operator overloading. So this is also one kind of class. So whatever the things that you are seeing in OpenFOAM, so these concepts like field meshes, discretization schemes, interpolation schemes, equations of state, or there could be spray particle system, matrices, matrix storage format. So even parallel computing that you are going to perform, that all these concepts includes either function or the class, or it can be both function or the class. Okay, there is another advanced concept, that is the encapsulations. Okay, encapsulations mean that wrapping of the data and information into a single unit. Okay, so like example that you can see in the OpenFOAM, this is not required to understand in the depth, just you should understand the basic concept of the encapsulations. Okay, so there can be many examples, but one example is that FB Okay, so the data and related function of the finite volume. So first OpenFOAM create a finite volume mesh, and the important data and related function that is relevant to the finite volume mesh, that is encapsulated into the FB mesh. So whatever the things that we are going to perform in the solver, that we are going to do on the FB mesh. Okay, so we means why it has been done, because programmer who are making the library or making the solver, he has to understand the in terms of the mesh only. Okay, so you don't have to means go to the different information or data related information of the finite value mesh. He just to understand that he is working with the FB mesh. Okay, so once he calls the FB mesh, it is going to call the mesh object, and he has to perform the whatever the operations he wants to on the mesh only. Okay, so that is another advanced concept of the OpenFOAM, that you don't need to understand in the depth, but you should have some basic idea about the encapsulations. Okay, these types that we define generally in the OpenFOAM, that is also one kind of class. As that I have told you that like variable is one example. So when you define any kind of variable, that is a type, and this is one kind of a class in the OpenFOAM, or any C++ coding that you are going to use, that is one kind of a class only. Okay. Okay, so class structure, that you already know, that that has been already taught many times, that the class, if you are going to define a class, then there is a public type of the variables are the methods, and private methods. Private you can access within the class, and public you can access the outside the class. This things has been taught to you many times. Okay, and in there is concept of the inline functions. Okay, so what is the inline function? So means maybe I have given one example in one of this folders that you can go. Okay, there are many examples I've added, so you can go through these examples. This concept I have given one or other examples. Okay, so what is the inline concept? That means function will be inline to the code where it is called, instead of the jumping to the memory location. So when you want to avoid the memory allocation of the function, then this inline function is important. Okay, so sometimes it happens that you don't want to you want to do some operation on the some variables, but you don't want that this means this operation store some allocate some memory. In such scenario, this inline function declaration will be taken consideration. Okay, so if you want to see that what are the different inline functions. Okay, maybe you open one terminal. That is why you should not give your system to some different person. I have given my system to use some another guy, and this error I am getting. 1 minute. Hopefully now I should not get this error. Sorry guys, we have to work on this only. We are this error I'm getting because I have given this system to some another guy. Okay, still it is working. So if you find that what are the different function that this inline has been coded, that you can use this command, that find and I name and this star this I dot h. Okay, so let me show you. So we can go to the cd home src. Okay, and this error we are going to get. Okay, now I can use the command find minus I name. Okay, this star. Okay, and that you can put going to put dot I dot h. Sorry. Okay, so you can see that different this volume fields dot I dot h, pimple loop I dot h, solution control I dot h, find solution control dot I dot h. These are the different means header files that you can see, and there is inline function has been coded. Okay, if you want to see, we can go to and see one of the examples here. So maybe we can see these examples. Okay, so let me open it in the Genie and home src. Okay, we can go to this command. Okay, so I'm just want to show you that what are the different inline function are used in the OpenFOAM. Okay, so these are whatever wherever you are going to find this I command, ulist I.h, fixed list I.h, circular I.h. Okay, this X means different I auto ptr I.h, temp I.h. This there are only inline function has been coded. Okay, so we can open this. Okay, so you can see here that there is a one function is coded whose type is inline. Okay, that has the some template class. Okay, so this way these are the different function has been coded in the OpenFOAM for the inline class. Okay, okay, so you can a construction concept you have already known. Sorry, so iname is not a function. This iname that you are asking, that is the Linux command. Okay, so whenever you want to find some folders like that, what let me explain this command that I used. So this find command is a terminal command. Okay, so I want to find the folders. So whatever the folders name that you want to type, that you can type here with the iname. Okay, now star means that whatever the folders whose has the ending with I.h. Okay, so star, I think you are aware about this star in the OpenFOAM. So star means that whatever the means initials having this different name, and but the ending is having I.h, it is going to print those names. Okay, now suppose I want that whatever the folders have .c. Okay, so this way you can use this iname command, and it is going to this the current folder, that is the src folder, and using this find command you are going to find all the folders who has the this source name, that is a .c. So that is important of the star here. Okay, so then when you are going to use, you can see that whatever the C files are given here, that is going to print on the terminal. Okay, so this iname is the terminal command, not the any function here. This is not related to the C++, even means not in the OpenFOAM, not in the C++ concept. Okay, now constructor, this concepts already you have means have idea about this different constructor things, that what is a constructor, what is the null constructor, why this important of the copy constructor is there. This all concept has been covered. This why friend function is important. So sometimes it is important that you want to access the private data or private member function. In that scenario, this friend function is important here. Okay, so whenever we create any constructor, it automatically you can copy that value of the constructor into the different variable. Still there is a requirement of the copy constructor. Why this is important? Because this defining a custom copy constructor is necessary to avoid the shallow copy. Okay, so sometimes it happens that while you are copying one constructor value to the other constructor, then it can lead to the shared resources problem or dangling pointers. Okay, I think this all concept I have explained in the folders that I have shared with you. You just go through these folders and you have means all these things I have written in that folders. Okay. So now I think you have many things you have understand about the class. What are the different functions of the class? What are the functions? These different things you have understand. Now let's take one example of the dictionary. Okay. So I think some of the examples have been taught by the Nikhil. So I'm not going to create a separate folders or separate thing. I'm just going to show you that what is the Doxygen and how you can use that Doxygen to access the different information here. Okay. So how you can understand what is the Doxygen? So let's open one uh, terminal, and here you can type here OpenFOAM Doxygen 6. Okay, so at this level you should have idea that how this Doxygen you can use for your programming purpose. Okay, so this Doxygen you can use here. Okay, otherwise you can also go to the this OpenFOAM folder, and in where you have installed there is a doc folder. From here you can create your own Doxygen here. Okay, so you need to run this all make command. If you run, it will create one Doxygen folder, and that you can use, but that is the same utility as you are seeing here. Okay, so there is no difference between that Doxygen and this Doxygen. So as long as you are working with the proper internet, you can use the internet version of the Doxygen here. Okay, now we have opened this OpenFOAM 6 version. So once you open this OpenFOAM 6 Doxygen, here the version 6 would be written. Okay, and this is about the OpenFOAM, and this is the different directory structure that is being given on the OpenFOAM Doxygen. Okay, now here you can see that there different name spaces are given, different classes are given. Let me zoom a little bit. Different classes are given and different files that are important. What are the different functions, variables, and type defs and macros? These different things are given here. Okay, so if you open the namespace, so here two namespace is important, and for us this form namespace is important. So this is specifically for the OpenFOAM. This CGL is for some other utilities. Maybe I'm not I'm not aware of this CGL these things, because I've not used this for namespace. But whatever the OpenFOAM coding has been working, the different coding of OpenFOAM is done in the OpenFOAM namespace. Okay, and that namespace form namespace means while you are going to do the coding. So if you open this any folder, you can see if you are hiding this fbcfd.h, then you have to write explicitly that using namespace form. If you are not using this fbcfd.h, then you have to write that you are using the namespace form. Okay, so that is why this fbcfd.h is very important, because whatever the prerequisite for coding in OpenFOAM, either you are developing a solver or developing a library. So whatever the prerequisite is required, that is already coded in the fbcfd.h. So maybe we can start first with the fbcfd.h only. So if you type here in search bar fbcfd.h, so you can see here that it is suggesting one name, and you can open in the another terminal. Okay, so you can see here that it dependency in the OpenFOAM of the fbcfd.h. Okay, so these are the different things that you are seeing here. Okay, that has been derived in this fbcfd.h. Okay, so if you open this source code, you can here see that it is written that go to the source code of this file. So if you click on this link, then you are going to see the open this fbcfd.h. Okay, so you can see here that these are the different header files that has been coded in the fbcfd.h, and here you can see here that this using namespace form is written here. Okay, so as long as you are going to write this fbcfd.h, these contents are already going to be defined here. So these are the basic things, that is the time, fbmes.h, fvc.h, fvmatrix.h, fvm.h. Okay, calculated fvpass.h. Okay, constant.h, adjust5.h. So these are the basic things that has been already coded in the OpenFOAM. As soon as you are going to write here fbcfd.h, this criteria you are already fulfilled. Okay, so if you are writing here fbcfd.h, then you don't need to write here using namespace form. Okay, so that is something that you can either use here using the Doxygen, and you can go here directly and you can see here that these are the things that has been already derived or already inherited into the this fbcfd.h. You can see here that these are the files. This arrow means whenever you are going to see this arrow sign on the Doxygen, so it means that these are the things, these are the header files that has been already derived in the present file, that given file. Okay. Okay. Now here the arrow signs means that FBCFD is derived in this two, this model.h and patch summary template.h. So this arrow signs means this, it has been inherited into the these two folders. Okay, here it means that these are the different things, that is the time.h, fbmes.h, fbc.h, fbmatrices.h. These are things are inherited into the this FBC update. So I think you have a basic idea about what is the inheritance. Inheritance means the capability of this whatever these classes are given here, the capabilities of the method that has been defined here can be accessed through the this base class. Okay, so there is a two class, that is the base class and that is the derived class. So these are the function that has been inherited into the base class. So base class can access the all the public functions of public method of this derived class. Okay, so this is something that we understand from the FBCFD. Now that, as I told you, that we have to understand the dictionary. Let me go to the dictionary.h. So we have to go to the small dictionary.h. Okay, so as soon as you are going to open this dictionary.h, so these are the structure that you can see here. That, so it means that, again I am explaining that these are the things that you are seeing the red box and the arrow signs is given here. So whatever these things you are seeing, that has been derived into the this dictionary.h. Okay, so these things are inherited into dictionary.h. So whatever the functionality of this function are given, this hash table, word list.h, class name.h, file name.h, these are the capability that can be accessed through the dictionary.h. Okay, now here what are the different classes are given here. So here two classes are given here, that is the dictionary name and second one is the dictionary itself. Dictionary itself is a one class. Okay, now namespace, you can see here that different functions are given here. Okay, so let me go to the this source file. Okay, so this is the source file. So if you want to has just some basic concept you want to understand, you can go through this simple one page and you can understand that what are the different things has been inherited and what are the definition of this class, what are the different functions. This is the some give you some basic idea. But if you want to go through the source file, this is the source file here. Okay, here the definition has been given here. Okay, so now here, so first concept that is, you can see here that here is the namespace. So these are the different things that has been derived. So you can see here that this entry.h, id list.h, hash table.h, class name.h, this header files are included here. Okay, so this is the where this header file is included. Now you can see here that starting from the namespace form, you are going to see this forward declaration. That is something that we have not discussed yet. What is the forward class declaration? So sometimes it happens that you want to declare some class, but you want to that the definition of this class will be given means later. You just want to use these classes, but definition you want to give in the letter means letter of this source code of the dictionary.h. So in that scenario, you define this forward class. Okay, so that is also some advanced concept, but you should have idea that this forward class that you want just you just declare here, but definition that you are going to give in the later version. That is why this declaration is defined here. So let me give you one example. Like if you have given one class, you have created one class that is a dictionary. Okay, so this dictionary you have just defined here, you are not giving a definition here. Before that dictionary, you are giving a dictionary of the dictionary name. Okay, before giving a definition of the dictionary, you are giving the definition of the dictionary name. Okay, so you can see that till here you are giving the definition of the this dictionary name. This is not the dictionary class, this is the dictionary name, the class. Okay, after that you are giving the definition of the dictionary. Okay, so that is why this forward class is used here, because you want to use some capability of this dictionary. That is why you have created one forward class. Okay, and here you have given two operator also, that is the means for printing in or printing out. Now you have given the dictionary name class, and that this dictionary name class that you are going to use into the dictionary here. So you can see here that, so I think this dictionary name you can just go through it. This is a simple starting from the, you have created some private data. Already you know aware about what is the private data, and here you have this constructor concept. So we have this null constructor that I've already, Nikhil told that what is the null constructor and why this null constructor is important. Okay, this is the constructor that you are declaring, who is taking one input parameter. So this is the dictionary name that you have cleared, and one input parameter that you are giving as a argument. Okay, and what the value of argument will be defined as the name that you are declaring here, and it is going to be stored as the name dash. This is the one constructor concept, this is the null constructor. These two concept already we have understood into the earlier classes. Okay, now here this member function has been, definition has been started, and you can see here that these things are the private data, and this member function and this constructor that we have defined, that is the public data. Okay, so this file name, this is the private data. So whenever you want to access this file name, so you need to use the public property. So either you are going to use a public method, then you can only access this file name. Okay, so these are the member functions. Okay, so different member function you can see. This is the dict name. Maybe some of the member function I have given in this this either one of the, means any of the these two examples we are going to see here. It will not take much time because I've already coded, so it is not going to take much time. Okay, so I think this, now you can correlate the things. So whatever that you understand in the functions or the classes or the inheritance concept, now you can understand the things here. So these things, you are the private data, this is the constructor data, this is the different member functions. Okay, and now you can see here that this dictionary name, that class that you have defined here. Okay, this class that you have defined here, it is going to be inherit into the dictionary class. Okay, so this is the way of inheritance. This is a concept of the inheritance that you have understand into the earlier classes. Okay, so this dictionary name is already means also inherited, and this ID list is also inherited in this dictionary concept. Okay, so in your basic examples we have just done, we have taken only one drive class, but here you can see that there are two classes are being derived into the this dictionary. One, this is the dictionary name, and the another is the ID list that you are defining here. Okay, now here again you are declaring some private data. Okay, so these are the some different function, this different private data you are declaring, and here also you have this some member function that is also a private member functions. Okay, so these member functions that you can use only for the dictionary here within the this class. Out of this class you cannot use either this private data or this private member function. Okay, now here are the some public data. Okay, so these are the some public data. Okay, and here this is the null constructor. This is the constructor that is taking one argument. This is the constructor that is taking three argument. Okay, this IS system is some concept of the virtual function or the abstract class. Okay, so I will show you that what is this IS system and what is the abstract base class that I'm going to show you. You will understand in by taking this concept. So this abstract class is not covered in your while studying the class concept. So you have not understand this, what is the abstract class concept. So I am going to show this example that what is the abstract class and why this abstract class is important here. Okay, and how means I will also show you some of the examples in OpenFOAM. Okay, here are other some, there are, you can see that there is a lot of the constructor here. In the case of the OpenFOAM, generally you are going to see all different type of the constructor in OpenFOAM. So in OpenFOAM there is not only one or two constructor. In OpenFOAM you are going to observe there are many type of constructors defined. That is taking a null constructor, it is taking only one input, it is taking three input, here also it is taking only one input. Okay, so these are the different concept of the constructor here. Okay, and now here you can see the destructor. Already told you that what is the concept of the destructor, and also I have attached a folder, you can go through it, and there are the public member functions. Okay, so here you can see that different public member function is defined here. Okay, so let me show you some examples starting from this example one. So here first we are going to start with the dictionary name. Okay, so we are going to use this first concept, that is the this dictionary name class. So this class we are going to use, and let's use some of the capabilities of this. So here you can see that there are two constructor that it can use to construct an object of the dictionary name. So if I open here, so you can see that I have taken this not the null constructor, I have taken this second type. Okay, so here I am creating one class using one file name. Okay, so I means I have taken one object, and I am creating one means constructor one object using this input, that is the file name. Okay, so if you open this, here you can see that there are two functions. Okay, so one function is the, that is means that is the taking the dictionary name, and it is going to print the name. Okay, and the only difference is that it is a const and it is a not const. Okay, and here one the second function is that is the dict name. Okay, so the difference between this name and this dict name, that it is not going to print the other character. Okay, what I mean to say that when you are going to type file name dot name, it is going to print this file one with this character, that is the semicolon. But when you are going to use this dot dict name, it is not going to print this semicolon. Okay, so it is a simple code, and let me just compile within. Okay, wclean.m and wmake. So if I run ex1, okay, sorry, I have not saved this. I need to save before compiling. So you can see here that the first function printing with the semicolon, and second function printing without the semicolon. So that is the only difference between this this function, that is the name, and that is the dict name. Okay, so this is, you can see that you can use this class name in the member function from using the Doxygen only. Okay, so if you have some basic about that, what is the this class, what is the constructor, what is the private data, and how you can use the private data, then you can use this using the Doxygen concept. You can use the, you can create your own solver or create your own library. Okay, now let's see some example of the dictionary that I have coded in this ex2 examples. Okay, so see, first we are starting from the this constructor. So let me parallelly open this dictionary concept. So we are creating this first constructor. Okay, so it is asking this file name. So you can see here that, so we are asking this file name. Okay, we can correlate here. I'm just going very fast. I don't want to give much time here. Now this is going to print this, whatever the value that you are storing, it is going to print that what is the dict one. Okay, so since it is a null constructor, it is going to print you a null dictionary. Okay, Now we want to add some value, so maybe some member function, that is the dot add. So from here to here, these all are the constructor concept, and here the destructor, and here you can see there are many member functions. So I have taken one member function, that is the add. Okay, so you can see here that this add concept, we want to add this null constructor that we have created, we want to add some value. Okay, so this dictionary is a concept of the hash table. Why are we looking at .sh files? Why not see this header files? Means whenever you are going to see, there are two things, that is the header files and the source files. In header files there are only definition are given. Okay, so the if the means whatever the means what is this function is working here, whatever the capabilities of this function is coded here, that is given in the source file. Okay, so this is just a declaration. Okay, so for example, if you're going to do means if you're writing a simple code like int a plus b, this is the functionality you want to add two number, that is a plus b. So first you have to declare a and b. Okay, so these are the just declaration of the different member function and different class. So whatever the operation that you are performing, that is coded into the .c folder. So if you are going to see that .c, it is more lengthier than this .h file. Okay, so that is why some basic idea is given in the .h, and it is always better to see the .h. And if you want to understand the functionality of these functions and how it has been coded, how it has been given, then you can go to the .c. So .c is a very lengthy file. So that is why all this it is better to. So let me show you .c. Then yes, you can so go here, and you can see here that these are the different member function that you can see here that the functionality is defined here. So it is means it is very complex to understand at this level. Okay, because it is a very high advanced level of C++ programming. So you have to just understand the basic things from the .h here. Okay, that is why we are looking at the .h only. Okay, now you can see that we are using one member function, that is the .add. Okay, and here so this dictionary concept is the concept of the hash table. So if you have understood about the hash table, so hash table should have a one means value, and this value one keyword, and this keyword should have a one value. So this is known as the dictionary concept. So here I have a one keyword as the my value, and the value of this keyword equal to the 0. Okay, so this is the way that dictionary should be defined here. Okay, and now you can see that let me show you that which member function I'm using. Okay, so here you can see that I am taking one keyword, that is the okay, so I am taking one type, that is the key type, and this is the my value, and I am giving one value equal to string. So this is the 0 I am taking as a string, and this is where I have to write that I want to overwrite it or not. Okay, so if I want to overwrite it, I should write here true. If you want, I don't want to overwrite it, then I should write here false. So this is the member function that we are using. So this I have defined a class of the dictionary, and here I am using the add member function, and we are going to again print it, that is the dict1. Okay, so this is the first coding. Okay, now this again I'm using the second constructor. Maybe I can start okay, so means this is just copied from here. So this is the second member function, second this constructor that I'm using here. Okay, so this is the second constructor that I'm using here. Okay, so this is that completely I copied from here. Okay. And that is here the definition. You can see here that here what you are giving. So first I am giving a file name. So already one file name is defined here, that is the dict1. Okay, and I am also giving the dictionary, that is the parent dict. So this parent dict I am taking as a dict1 only. Okay, now this is the IS stream. That is important that is important concept that I want you to understand here. Since IS stream is a concept of the abstract class. Okay, so what is the capability of this abstract class? So this abstract class, you cannot create abstract class. Okay, it means that you can only use the means capability or the functionality of the abstract class into the derived class. You can directly cannot create uh, a object of this given abstract class. Okay, I mean today as you cannot create a object of this IS stream explicitly. If you want to use the means concept of what are the member function or what of the method is given in the IS stream, you need to derive it into the some other member function, other basic class. Okay, so what you can do, either you can create a pointer or reference to this IS stream. Okay, so because the IS stream is a abstract class. Okay, so there will be at least one method. So what is the this abstract class? So there will be is going to be at least one method where you are going to find a virtual function equal to the 0. Okay, and this is used to tell how the subclass should be defined. Okay, so it means that as soon as you are going to define a virtual function or abstract class into the some another class, that member should be also going to be defined always. Okay, so let me show you that IS stream, then you are going to understand it. So if I type here, okay, I can directly go from here. So if you move your cursor on there, you are going to see the definition here. Okay. So if I go here, so you can see here that it is an abstract based class for all the input system. So whatever the input system is working in the OpenFOAM, streams, files, or token list. So this is the abstract based class for the those input system. Okay, so basically what is this IS system is do? It reads the different files. Okay, similarly there is going to be the output stream. Okay, so these are the basic class that is going to be derived in the all the input classes. Okay, so if you go here, you can see here that what are the different function is going to define here. There is a virtual concept equal to 0. So that is what I am saying, that there should be a virtual and there should be a name of the function, and then function name equal to 0, then it is going to be called as the virtual function, virtual member function. Okay, and these are the classes that are called as the abstract class. Okay, so if you go to the SRC folder of the OpenFOAM, so let me open one terminal, and we are again going to see this error. Okay, so let me create OF6, and we can go to the file foam SRC. Okay, you can type here in your terminal, find iname and into semicolon. No, sorry, this is not going to work. Let me show you here, grep minus r, and okay, so you can see that there are large number of virtual classes are created. You can see that there's you cannot count even these numbers. Okay, so these are the classes, that is the virtual classes. This searchable plain .h, these are acting as the abstract class. Okay, so whenever you are going to call means they inherit this class into the another class, you are going to call it as a abstract class. Okay, and whenever you are going to inherit this class, this definition should be available here. Okay, So if you see here that this is_stream.h, these are the definition. This read definition should be present in this dictionary.h. One minute. See this definition, that is the read stream. So this definition, whatever the read definition is there, this function should be defined in the this derived class. That is the means that is the base class. Okay, so this is the concept of the virtual function. So whenever there is a virtual function is defined in the derived class or in abstract class, if that abstract class is being called here, okay, so then the definition that is defined in this abstract class, those definitions should be available here. Okay, so there are many concepts that you can see here in when while you are going to call the this viscosity model that you are going to develop. In viscosity model there are many virtual member functions, in means in other many libraries like that I have shown you that there are many libraries that are defined here. Okay, maybe I can show you another examples that you can correlate with maybe some physical example that I can show you. Okay, so let me show you that radiation model.h. Okay, so this member function that you can showing to that virtual void correct. This is generally available in every model that you are going to develop. This calculate equal to 0, and these are the virtual function that should be defined here. Whenever you are going to use this radiation model, if you are not defining this correct function or this calculate function, it is going to show you error. Okay, so let me show you in the src folder. So if you go to the src folder of OpenFOAM, and where this folder is thermophysical model and radiation. So this is the src folder. If you go to the thermophysical model, and here radiation, if you go, okay, and here radiation models and radiation model. Okay, so if you are open this, maybe in the Genie, so you can see here that this is also a virtual function. Okay, so whenever going to call this radiation model.h, if you are going to derive this class radiation model.h in any other, here you can also see the forward declaration of the class that I already told you currently. So whenever you're going to call this radiation model.h, then this definition should be defined here. This two definition, this calculate is equal to 0, this is also a virtual function. This read function equal to 0, this is also a virtual function. This is also a concept of the abstract class, and this function should be defined here. So let me show you one example here. Suppose I am taking this FB dome example, or maybe simpler, this no radiation.h. Okay, okay, so you can see here this radiation model.h is called here. Okay, so as long as it's called here, you can see here that these are the member functions that is already defined here. If it is not going to define here, and if you are inheriting this radiation model.h, it is going to show you error. So that is why this virtual function is important for you. Okay, because as long as you know that if you are going to use the radiation model, these two values are important for using the radiation source model in the temperature equation, or whenever you are going to use the radiation model, these two values, that is the rp and ru, is important. That is why you are defining it as a abstract class. So whenever a guy is going to create some new radiation model, these two member functions should be defined. Otherwise, this source term for the radiation model cannot be calculated into the temperature equations. Okay. Yes, yes, you are right. So who is this? Yes, this is equal to 0. That yes, you are right. It is a default contract constructor in the base class. You are means correctly right. Okay, so I think enough for this abstract class, and that is why we are creating one IS stream. Okay, and once we have created one object of IS stream, we are calling this in this constructor. Okay, so I have called this file name. This is a dictionary that I am taking the parent, that is the dict1, and this I am calling this as a IS stream. Okay, so this is the one constructor, and again I am going to print here. Okay, this is I'm using another constructor from the that you can go through it. Just I think it is I'm taking too much time on the dictionary only. So this is another constructor that I'm using here. Okay, and this is using the copy constructor. Okay, now again I am printing this fourth constructor. Okay, just go through it one by one. Some means I've given a number of examples here, and I have also given some comments. So try to look at this is a very important member function. Just look up. So whenever you want to see some value from a given dictionary, so you already know that in OpenFOAM, whatever the test case that you are seeing, you work on the only the dictionary only. Okay, so whatever the in the 0 folder you are seeing, in system folder you are seeing, so you are seeing only the dictionary only. So you are working with the dictionary only. Okay, what is the input output concept? Although you are working with the input output index and the system, here I am showing just the showing the capability of the dictionary. We are going to see this input output dictionary a little bit later, but whatever we are working in the OpenFOAM, that is the concept of the dictionary. So this is how you can look up a function, or you look up a value using the lookup or add or default concept. Okay, so if you going to see again in the SRC folder, and you can see that how this member function is important in the OpenFOAM. Okay, so you can see here that this lookup or add or default is defined in the many of the folders here. Okay, now if you just type the lookup only, so you can see here that there are different means you are seeing this concept of the this member function. Here is the lookup. Yes, this lookup or default. Okay, lookup or default. Okay, this lookup type. Okay, this lookup. So these are the different capability that you are seeing here, that is taken from this dictionary dialog. Okay, you can see that dict.lookup is function is being used, and it is looking the value for the E3. Okay, so that concept is taken from the this source file. Okay, so now I think you can relate the things. You can see the code from the Doxygen, and you can find the function that is being used in your code. Any SRC folder, any library you can pick up, and you can relate the thing, what are the member function, where it has been called. If you want to see, you can just go through the this what are the different file has been inherited, different forward class you can now correlate, how to construct a constructor you can see, and you can relate with the Doxygen. Okay, now what are the different member functions are being used, that you can relate with your code. Any code you can see, and you can find the function, find the member functions, and you can just means you can now decode it. Any type of the complex code, you can at least decode it. You can not create by your own, but you can decode it, what are the different things is given here. Okay, so this is what I want to make you understand here. So here you can see here that means this lookup or default is a kind of a template class. Okay, so if I show you here, so these things, yes, these things. So this is a kind of a template class. So here we are taking a vector. Okay, so vector is have a 3 direction. So I am taking 3 components of the vector v2. Okay, now this I adding this I am try to either find this value or add this value. So this lookup by default means if there is no any this vector, then you add this vector into this given dictionary. Otherwise, if there is already this vector is available, then you just you don't need to do any operation here. Okay, so now this template is vector, and if you want to put some scalar, so just you have to define a scalar here, and here you have to give the template equal to the scalar. And now this value is going to be decoded here equal to the value my6, and this value equal to my6 equal to the v2, the value that you have defined here. Okay, so let me just run here. Okay, so these are the different things. So starting from the null constructor, so starting from the null constructor, so we have first started with the null constructor. So you can see here that this null constructor has no any value. Okay, now is I have added some value equal to the 0. So you can see here that this is kind of a hash table. So there is one keyword, and keyword has a value equal to the 0. So this is the second constructor, third constructor. Just you can visit the different things. Okay, and here second constructor. Here let me just to show you this last one that we have shown, that is a lookup by default. Okay, so you can see here that this is the lookup by default, where I added one value, that is the my value equal to the 6, and I'm taking it as a vector v2. So you can see here that 0, 0.4 and 0.9. So this value I'm adding as a vector quantity, and you can see here that this template I have taken as a vector. Okay, so just go through it, this different example of the this dictionary here. I will add here this folder into the your cases. Okay, so just I wanted to show you that how you can use the Doxygen. Okay, so you can just go through it. Okay, just go through it. Okay, and I will suggest that means I am seeing that many people are trying to learn many things, but they are very means little bit afraid of doing modification. Okay, so don't be afraid. If you want to learn anything, just try to copy these things folders from here to the your run folder. Just one rule you should know, that you should not touch anything from this default installation. So don't touch anything in this. You can copy any folder, any solver, any test case from anywhere, and just copy to the your run folder, and try to just change the this little bit, and you can just go through it, and you can means learn from your side. Okay, so I will suggest that this application has this test file, and you can go through the different things here. Okay, here this dictionary is given here. Okay, there are different test cases are given, different this source code you can open here. Okay, and you can just means try to understand everything by running this .c folder. So just copy it from here and paste in your own run folder. Okay, here you can paste anywhere, and try to understand from here. Means don't afraid of just modification, doing modification here. If you are afraid of everything, means you are not going to learn this concept of the C++. Just try to, this is the way I learned. So when I started in IIT Bombay, there was no one in IIT Bombay to teach me that how to work. So in that situation, I just started learning by myself. Okay. Now another very important concept is the concept of OpenFOAM is the runtime simulations. Okay, so this is the beauty of OpenFOAM, that if you see that means if you are running it, means there is a one solver that is known as the app, and when you try to solve any model, any problem, or any physical model, or any governing equations, you you have a solver that is known as the app name, and you have a test case. Okay, and if means at the runtime, if you are doing some modification, generally if you run a C++ coding, if you want to do modification, then you have to do the modification. If you want to even change a variable name, you need to do the modification to change the variable name into the .c folder, and then again you have to compile the that .c folder, and then you are going to get the result. That is the general way of means C++ programming if you work with. But this is the beauty of the OpenFOAM, that if you want to do any modification, you just directly go to the system folder or constant folder. You can just go to the thermophysical models, thermophysical properties. You can just change the value, and it is while running the simulation, it is going to change the value. Okay, even after some iteration, if you are changing the FB solution dictionary or FB scheme dictionary, it is going to work on that value, that dictionary value, and that is the value. That is the one of the means beauty of this OpenFOAM, that it allows the runtime simulations. Okay, so means an object of a specific class is chosen and inserted at the runtime based on the read parameter, and this is applicable not only to the boundary condition. This is applicable to the applications also, dictionary file also, and of course this boundary condition is the part of this dictionary system. Okay, so this runtime simulation works on the this different things. Okay, now this application, when I talk about the application, this is not only the solvers, this is the utilities, this is the solvers, and this is the of course the post processing utilities. You can this already you know that if you go to the form app, these things are available here. Okay, now this dictionary already I would told you that what is the dictionary. Okay, so this is a kind of hash table, and this structure is used to often in the OpenFOAM to relate some keywords to the key values. Okay, and this is also a concept of the runtime simulation. Okay, now this how runtime simulation works in the OpenFOAM, how this coding has been done. This is a very advanced concept, and you don't need to understand at this level. Okay, means even I go through the many books, and in those programming level books of the OpenFOAM and even in user guides, this concept of the runtime simulation means from the coding perspective, it is not given in any book. Okay, so this is you don't need to worry about this, but you should have some idea about that how this runtime selection works. So so this means this allows to configuration, do the configuration during the runtime, and OpenFOAM can read these changes while working during the simulation. So this is kind of the runtime simulation. Okay, and it works on the any means any dict file given in the OpenFOAM. So it is going to work on that. Even it is the boundary, it is the FB scheme, FB solution, it is the control dict. Okay, so different dictionary files. If it is the dictionary file, so this runtime selection is going to work for that system only. Okay. Oh, so these are the different things that you are going to see. So these all things that I'm given here, that discrete differential operations, explicit observation, implicit operators, these all are related to the dictionary file only. Okay, so that is why this dictionary file is important. So whatever the concept that you are seeing here, that is the namespace, function templates, this all is starting from the dictionary files. It is going to read the dictionary file, and it is going to operate this divergence, gradient, Laplacian, and curls. Okay, this implicit operator, explicit operators, I have already told about this. Okay, so explicit means it is going to means result in a new field. Okay, but implicit operator is there, it is going to just modify the matrix. Okay, so there should be matrix, and that is going to modify that matrix value, that is known as the implicit operator, but explicit operator is going to give you a completely a new field. Okay, so just means some basic about this runtime simulation I've given here. Since I'm not giving you any coding, so just means I will going to attach this PDF. This PDF, you just read these PDFs. Now, this very important concept that I am going to discuss, that is the object registry. Okay. So what is the object registry? So this is also a hierarchical database. Okay. So that is OpenFOAM uses to organize this model related data. Okay. Now, since whatever the things that you are going to work on in for your problem, so you are going to use a app, means that is a solver, and you are going to use that solver for a given like test case. Okay, so as long as you are going to use this solver for your problem, so it is going to create a database. Okay, and database has a hierarchical system. Okay, I am going to show you that how this database is going to work. So this is the database required, because suppose after doing every simulation, some other user want to use the simulation results for their other purpose. Suppose he want to use for means from after a given time step, he want to use the data to do other simulations, or he want to do some other post processes. So this database object registry is required, so that any other user or even you yourself, you can use the database to do your or another work, another operation. So this is why this OpenFOAM works on the object registry system. So it makes a list type of a database, and the list type, how this makes the list type database, that we are going to see by taking examples. Okay, so first, so there are three components of the object registry, that is the IO object, registered IO object, and object registry. Okay, so first, this what is the object registry? That is it is a hierarchical database which uses to organize its model related data. Okay, so model means that operation that you are performing, the governing equation that you are solving, that is the model. So the any type of related data related to the model, it is going to organize in a database, and that is known as the object registry. Okay, now what is the registered IO means IO object? So the standardized input output support that uses by the object registry, that is the known as the registered IO object. Okay, so during the runtime, whatever the means value that you are printing using the input output system of this OpenFOAM, that is known as the registered IO object. Okay, now how these three functions, three components are related to one each other, we will understand from the Doxygen. Okay, so give some time. Okay, so this IO object, it is automatically managed to registration and deregistration of the object. Okay, so that is why you can see that whenever you create any variables in OpenFOAM, so if you go to the solvers, so as soon as you are going to see this solver, so there is a create field.h. Okay, so you can see here that you are not just doing the declaration that volume scalar p. You are using the concept of the IO object, because you want to that this whatever the variable that you are creating here, that should be the form of that should be listed in the object registry. That is why we use the concept of the IO object to declare this object, that is the volume scalar pressure field. Okay, so if you are going to create this variable as a volume scalar field p, just by in this manner, just by taking this, and you are just doing this declaration like this. Okay, it is going to declare one variable of p, and who has the means means property of the value scalar field, but this p is not going to be the part of the database. Okay, because it is not using the concept of the IO object. Okay, so if you want to use the concept of the IO object, if you want that this variable should be listed in the object registry, so then it should be defined in such way that it should be use the capability of the IO object. Okay, so that is why this IO object use the registration and deregistration of the object. Okay, so which variable you want to register and which variable you want to deregister, that concept should be comes from the this IO object concept. Okay, so this is the this structure of this object registry. Okay, so let me go through the Doxygen. So let me go to the object registry.h. So now you have concept understand that what this now you have basic idea that these are the inherited class in the object registry. So this registered IO object is inherited into the object registry.h. Okay, so these are the these things that you can see that means what are the different means header files that he inherited the object registry, that you can see here. But currently we are understanding the object registry, so I am focusing on the this header file only. Okay, now it is also using the foam namespace, and I can use the open the source code. Okay, so here you can see here that this is using the So you can see that this is using the this is inheriting the registered IO object, and this is using the hash table. Okay, so this is the some advanced concept. So here you can see here that two inheritance is being done. This is the base class, and this is the class that has been inherited into the object registry. Now this is the registered IO object itself is being inherited into the object registry, and this is creating another hash table of the same object, that is the registered IO object. Okay, so this is the some basic advanced concept, means registered IO object creating a hash table of itself only. Okay, so one object it is defining, so you can use the capability of the registered object. Again, it is using the hash table of the same object, that is the registered IO object. Okay, and if you go to the, say, there are some private member function. Okay, and this is the public. And if you go to the registered IO object, let me show you this registered IO object. Okay, so you can see here that here this IO object is being inherited, and that I want to show you that. So this first, this IO object is being inherited into the registered IO object. Okay, so you can see here that this IO object is being registered into being inherited into the registered IO object. So whatever the capability of the IO object is defined, that is automatically is being defined in the registered IO object. Okay, so you can see that this is the IO object, and there is the registered IO object. Okay, now this registered IO object, we have a member function, that is the virtual member function, that is the write data, that is the abstract class. So if I open the registered IO object, so this is the no, this is the registered IO object. So if I go here, you can find here that there is should be one member function, that write equal to the 0. Okay, so you can see here that this write data. So this is the virtual function. So whenever you are going to inherit this registered IO object, this member function should be defined in that object tree, that object registry. Okay, so if you go to the, since this object registry has registered this concept, this function is inherited into the object registry, this write data should be defined here. So you can find here somewhere this definition should be the given. So you can see here that this write data function has been called here. Okay, although it is not implemented here, but this function is being called here. Okay, so that is concept of the object registry. Okay, so I think this IO object, registered IO object, is clear to you. Now this registered IO object is inherited into the different things: dimensional field, IO input output dictionary, and this object registry. Okay, so the these are the different things that has this registered IO object has been called here. So you should know that this write data should be defined in everything. Okay, so let me show you that IO dictionary.h. IO dictionary.h. Let me go to the Doxygen. Okay, this is IO dictionary.h. Okay, IO dictionary.h. If I'm something missing. Yes, so you can see that this IO dictionary.h, okay, so it is used base IO dictionary.h first is created this class, and here you can see that base IO dictionary has inherited this this registered object concept, okay. Then after this means taking this base IO dictionary, this is inherited into the IO dictionary, and here you can see that definition of this write data is given here, okay. So this write data definition has been given here. Okay. So whenever this what means whatever the this dimensional field, IO field, input output field, IO dictionary object registry is given here. So the concept of this registered IO object and the virtual function should be defined in this all this function. Okay. Now this object registry has inherited into the time. Okay. So time is the high class object registry. So as long as you are going to run a simulation, this time database is first created, and based on this time database there will be list of the another all the object registry database, that whatever the variable that you are declaring, that is the pressure field, u field, miss is also one of the object. So this is the one kind of the list miss database will be created, and this is the system that it is going to works like that. Okay, so first there will be time, and for each time there will going to be the different object registry for the mesh class, for the for the different transport filter, and different things there should be. It is going means I will show you one example. Okay, so this is the means how this means this object registry, this is going to how this it is going to be work like that. So first it is going to create a one time, and then there is going to be one object registry for the parent, and this means this lookup one function that is given here that you can use to find out the any object means any object that is listed in this object registry database, that lookup object that you can use to find out that object here. Okay, so you see this time as I told you, this time already is one part of the database, that is means high class database. So as long as you are going to perform a simulation, this time is going to be present here. Everything is listed after the time will be part of this object registry. This polymesh is going to be work. So as long as you are going to create any field variable, so this polymesh is part of that object registry. So for the polymesh you are going to define the different field variables. Okay, and this cloud is something that is related to the parallel computing. So when are you performing a parallel simulation, this is the cloud computing that is going to work, you are going to work on that. Okay, now let me show you example. So I think I have already, let me copy this from here. Okay, so this hash table 2, hash table 3. So these things you can just show means I put some examples here and you can go through it. So how this hash table works. Okay, so hash, as I told you, that hash table had one keyword and it has some value. Okay, these are the some member function of this hash table. So how we can use to erase the keys. Okay, so these are the different things that you can just visit, and every things I have written here, that what is the capability of this things that you can see and you can visit here. So different this hash table examples I have taken from this test folder. Okay, so these examples I have not created by myself, just by going to this application and this test folders. I have taken these examples and just I have pasted here. You can just go through it and you can see that examples. Okay, now let me show you that this object registry.c. So first started with that I have started with just this set root case dot h is going to read the test case. Okay, so by default the test case is available, structure is available, zero constant and system folder, and it is going to read there, and now it is going to create a time object. Okay, that is the object registry. Okay, so as I told you that as long as you are going to perform a simulation, so it is going to create the first, that is the that object, that is the time, and it is the part of the database. Okay. Now you are creating another object, that is the mesh, and again it is using the IO object concept, so it is going to be the part of the database. Okay. So this is the mesh, that object that you are creating, that is the mesh. Okay. So this, as you can see, that this is working like a list. You create the time, then you create the mesh. Now you are going to create object for the mesh. Okay. So this is the, again using the IO object concept, so it is going to work for the this mesh only. Okay. So this is another going to be the part of the database. Okay. Then you are defining the velocity field. So this is the how it is going to work. So first you have a mesh, a time, that is the top of the database list. And then you are going to define a mesh, and then for the mesh you are going to define the P and U. Okay. And you can print here the names, and then that is the means names that is related to the runtime, and the object registry database related to the mesh. Okay. And you can see that how much data is available in the database. This is the db command that is used to know the number of parameters into the database. Okay. So this is the concept, let lookup object. This is also you can use to as I told you, that lookup object, you can see that what are the different object is available. So that earlier that I've shown you the lookup or default, that is related to the dictionary. Here I'm this lookup object is being used for the database. Okay. So if you see, this command is also being used in many times in the OpenFOAM. Okay. So this database, when you are going to define, when you are going to means do some modification in the library or boundary condition, in that scenario you just look up in the database. So suppose you want to do some boundary condition modification on the pressure field or U field or temperature field. So in that scenario, in that library, you are going to call this lookup object function, and this lookup object function is going to object registry database, and from that object registry database, it is going to find out that whether this temperature field is available or not, and from there you can means work on that. Okay. So you can see here that this lookup object is called many times. Okay. So you can see that we are looking for the volume vector field, that is kind of U. Okay. So you can see here that lookup object, cell motion U, dynamic mesh dict. Okay. This row name. So this row name you can define this row 5, or means a based on your means solver capability. Okay. Now he can see here that this solidification melting source, since this is related to the multi-region solver. So multi-region have two different meshes. Multi-region is not one meshes. Multi-region has two meshes. That is why it is looking for that mesh capability, and for that mesh it is looking for the lookup object for that volume scalar field and the T name. Okay. So I'm also going to show you the concept of the object registry for the multi-region also. Okay. So this lookup concept has been used, and it is looking for the pressure field. Okay. Now it is going to, okay, let me also print this object registry here also. Okay. So let me again compile this. We have 6 double clean. Okay. So now it has been compiled. So we need to have test case, because we have set up the test root suit. Sorry. This folder that we have called set root case. So there should be one test case folder, and we have 6. And if I run this solver that we have created, that is object registry. Okay. So let me open this and let me show you one by one. Okay. So first starting from here, I have created time field, and let me show you that what we are printing. Okay. So first means runtime is a means height means top list means top of the list. Okay, so for this runtime it is saying that there is only one region is defined. Okay, if you are going to run for the multi-region, this time should have the two regions. Okay, yes, I think you are right. So if you are defining the volume scalar field without IO object, it is not going to create any database for that purpose. Okay, now when after this, when you are printing object registry that is related to the mesh, then you can see that there are 30 database. Okay, so whatever things are defined in the system folder, constant folder, and the zero folder, all the things are going to the registered in the database with related to the mesh only. Okay, now you can see here that it is showing that means database equal to means what is the this database system, it is showing that there is only one database. Okay, that is shown here in only this region 01 and region 01. Okay, now what I want to show that you can see here that this is printing the p old value. So you look up for a object that is the p, and you are storing those lookup object into the p old. Okay, and you are printing here. Now again you have printed this database. Okay, so you can see here that although we have created one volume scalar field that is the p old, and we are storing this value of the p into this p old, but you are again seeing that there is not any modification in the database. So this is, I want to say that if you are not using the concept of the IO object, it is not going to be the part of the object registry. Okay, so as you can see here that this p old is the not part of the this object registry. Okay, and this is the one another this what I can say that this is the function member function of the object registry class. Okay, so this is just going to find out that whether this u vector field is available or not. This is just this simple concept. This is the concept means these are the member function that I've taken from the object registry.h, and you can see that there are other many other this function I have used here. So this is going to just give you this bool means whether it is true or false. Okay, so you can see here that it is printing one, it means that it is true. So this value is present here. Okay, so this is something object registry related to the single region. Okay, now let me go through the concept of the multi-region. Okay, so this is the multi-region object registry. Okay, so here I have taken two meshes. Okay, so as far as I know in OpenFOAM, we have seen example of the multi-region, but not any single test cases or single solver I have seen where there should be a two time step. Okay, so that is why we always create only one create time.h. Okay, so that is why this time is the base means the top list of this object registry. Okay, so you are not going to find any programming or any solver or any model where there should be two time step. Okay, but there should be two meshes, as you know that. So we have created one first mesh, and the name of this mesh equal to fluid, and this is the second mesh that name is equal to solid. Okay, now this is the pressure that we have defined, and this is also a concept of the IO dictionary, and this IO object concept we are using, and this we are defining for the mesh 01. Mesh 01 means this fluid. Okay, and this again pressure we are defining for the mesh 02, that is the solid. This we are defining for the fluid, this we are defining for the solid, and here transport properties we are only defining for the mesh 01, that is the fluid. Okay, we are not defining for the solid. Okay, so how this database is going to work like, so first there will be time, and for this time there will be two meshes, that is the mesh 01 and mesh 02, and for different meshes there should be a database of the points, fields, transport properties, p and u, and for mesh 02 there will be only point, fields and p and u. There is no this transport properties. Okay, now another thing is important that this database is going to only understand the transport properties dictionary. It is not going to understand the this mu. Okay, because we are not using the concept of the this IO dictionary concept. So only from mu, from database you can access the transport properties, and from transport properties you can access the mu. Okay, but this mu is not going to list it into the this database. Okay, so again we are printing the names, that is the simple. And here for different object registry, we have to use the concept of the mesh01, mesh02, because we have two meshes. Okay, now again you can use the concept of lookup or found object. Okay, so this is the p old for the mesh01, this is the for the mesh02. Okay, and if you go to the test cases, this starting for multi-region, the test cases look like this. But when you go to the constant folder, this now this whatever the mesh is created here, this is should be defined in the fluid and solid. So this solid should have a another meshing, and this fluid should have a another polymesh folder. Okay, so as I told you that we are defining this transport properties only for the fluid. So you can see that transport properties for the fluid only, not for the solid. So there is no any transport properties folder for the solid. And this system should also be, there is a fluid and solid, and this is also fluid and solid. So in any cases, in any test case, if you are going to see, you are going to see only one control dict, because I told you that time is only one object. So in any database, time is going to be only one object that is going to be stored in the database. So you are going to see only one database for the control dict. But for other things, the FP solution, FP schemes, you should have two. If you are working with the three regions, there should be three folders. Similarly for zero, similarly for the constant. So if you want, you can delete these things. There is no use of this, because now these values are separately defined for the fluid and solid. Okay. Now if I want, I can run here of6 wclean.tel wmake, and we can go open this. I can call this multi-object registry. I can paste and run. Okay, now you can see parallelly with the code. Okay, so these things from here we are starting reading. Okay, so now you can see here that runtime has two regions, that is the solid and fluid. Okay, so now this time has two object registry, two database, that is the solid and fluid. And for different mesh, that is the mesh01, this has the 14 database, that is the transport properties included here. But for here, this there is no transport properties, because for solid we have not created any database here. Okay, so that you can correlate here. So transport properties we only create for the mesh01, that is the fluid, but we did not create any database for the solid, so you cannot see here. Okay, now you can see here that this again, this p-old is we are reading for the mesh01. Okay, and mesh02 we are just reading for the value vector property. Okay, now I think this is a very simple to you can understand here, and that I am showing you that that lookup object that I want to show you. Okay, so you can see that a number of list is there. So you can see here now this why this mesh is given here. Okay, this mesh lookup object is given here, because in the scenario of you have a multi-region, then this is going to ask for that which mesh you want to look up. So if you have mesh01, mesh02, so in that scenario, if you pass the this mesh01 as a argument into the member function or into the constructor that you are calling. So in that member function, it is going to ask take this mesh01, and from that mesh01, it is going to read this basic thermo.dict name. Okay, so you can see here that how this lookup object is going to go through the database. Sometimes it is even used to go through the database only. Okay, so this gb command that I'm showing you. Rupak, I think Lagrangian particles also in OpenFOAM, as I know that there is no two time scale. I've run for only one test case for Eulerian Lagrangian kind of problem, but there is also only one time scale problem. I'm not means aware of this multiple time scale. Okay, maybe I will be able to answer this question in the next time. Yes. Okay, so that is how this database and this mesh and everything works here. So I think this concept of the class and how this class is being coded in the OpenFOAM and how this object registry works, how the database works, how this you can access the different information from the dictionary, and how this lookup object you can access through. That you have a basic understanding about these things in the in OpenFOAM background. This is important to understand till here. From tomorrow class onwards, we are going to start working on the solver and the boundary condition. So tomorrow there will be two solver development, and after that we are going to work on the boundary condition and other means other advanced concept. Okay. So till now, whatever we have covered today, if you have any questions, just let me know. So I will attach these folders and try to run by yourself, and please go through each and everything. Today I have covered many things, and many of the top means many of the these folders I did not even touch. Okay, so please try to run from your side also. Okay, so this hash table you can go through it, and these are the different advanced concept that is not being covered in the OpenFOAM tutorials by the Nikhils. So you should also go from your side, and I've given everything. Means I have given instruction about that what is the Dixon copy constructor and why it is important here. Okay. So try to go through it. I'm also going to attach this PDF file, and please cover these topics by yourself also. And if you have any further question, you can just comment in the chat box here or in the OpenFOAM group, and I'm going to answer you that questions. Okay, so if you have not any questions, please thank you to all of you for joining this session. You can disconnect it now.